they already said it'll be more than 100. You ask them to be more specific and they say, well, it'll be more than 50. We already knew it would be more than 50. All of the numbers that are above 100 are above 50. Hey, this is Avi Gutman with another Ask Me Anything event brought to you by quantreasoning.com. I invite you to join me live next time. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial at quantreasoning.com. I want to ask all of you to look at those two statements and see if you can identify some kind of relationship between those two statements. You're right, Surajit. The inference from statement 2 is that the bill was $40-something. How does that relate to statement 1? They don't imply each other because from reading statement 1, we would not be able to infer that the tip was 8. That's right. So statement 2 implies statement 1. Let me put that another way. If you already knew that the tip was 8, would reading statement 1 tell you anything new that you didn't already know? So what answer choices can we eliminate without doing any further work? We can't eliminate D. We cannot eliminate D because I don't know what the question is asking. Maybe the question just wanted to know whether the amount was a positive amount, and then each statement would be sufficient on its own. Or maybe the question is, was the bill more than $10? Okay, then the answer is D. So I can't eliminate D when one of the statements implies the other, but I can eliminate A and C. Why? I go into this in the second section of my book. A can be eliminated because A claims two things. A claims that statement 1 is sufficient on its own, but statement 2 isn't. And that wouldn't make any sense here because statement 2 gives us everything that statement 1 had to offer and then some, even more. And it gives us an even more precise kind of information. So answer choice A doesn't make any sense, and answer choice C doesn't make any sense for a similar reason. I mean, answer choice C also says two things. It says that neither statement is sufficient on its own, but when you combine the statements, you get this miracle of sufficiency. And that can't happen. That miracle wouldn't happen if one of the statements doesn't add any information above and beyond the other statement. So for those reasons, we can eliminate answer choices A and C without even reading what the question is asking for. I mean, the question itself starts at the comma.
1 implies 2, right? Not 2 implies 1.
Oh, 2 implies 1 because 2 gives you the narrower range. So if I tell you statement 1, I'm in Canada, statement 2, I'm in Toronto, statement 2 implies statement 1. Knowing that I'm in Toronto, of course I'm in Canada. But not the other way around. Knowing I'm in Canada does not necessarily mean I'm in Toronto. So the narrower range is the more informative statement. When a new DS question pops up on the screen in front of me at the test center, I'm not starting by evaluating the statements and seeing whether one implies the other. That's not my thing that I do on purpose. But when I'm at home, I always look for that. And the reason is because the more I identify such relationships at home, the more likely I am to identify such a relationship by accident, without actually evaluating it on purpose, but it just kind of pops out at me at the test center. I'm like, oh, one of these statements implies the other. But the reason that it pops out at me is because I've always looked for that at home. I recall the last time I took the GMAT, I counted 3 of about, I think it was about 17 DS questions, and about 3 of them, or exactly 3 of them had inferential relationships in the statements. So it's not super common, but 3 out of 17 is not 0. I mean, it's not insignificant. And if the question is too hard for me to solve, then I'm much more likely to guess the right answer if I identify such a relationship. And I think also teaching students about this kind of relationship and how it means we can eliminate A and C, I think there's value in that even if you don't actually use the strategy ever. And where's the value? I think it drives a deeper understanding of the internal logic of the 5 answer choices. In other words, I think you understand answer choices A and C better now than you did 10 minutes ago, because we really broke down what exactly it is that they're claiming, and understanding why that doesn't make any sense when one of the statements implies the other. I think that drives a deeper level of reasoning, regardless of whether you actually use the strategy or not.
A bigger scope, it does not help you really to find the answer. But have you seen any question in which the opposite way, that
no,
is it a possibility that the bigger one helps you more?
Never.
Sometimes? Never?
Never,
Okay.
never. And the reason is that in data sufficiency, before we even look at the statements, there's always more than one possible answer. How do I know that there's always more than one possible answer without the statements? Because it's never the case that the statements aren't needed. Like, there's no answer choice in data sufficiency that says we don't need the statements. That's not an option there. We always need at least one of them in order to answer the question. So that means that there's always going to be more than one possible answer before we look at the statements. And what that means is that the job of the statements is to exclude some of the possible answers, right? How do you get to one definitive answer? By excluding all of the other possible answers. And what does it mean to exclude other possible answers? It means to narrow the range of possibilities. So the narrower the range, the more information I have. I mean, if you go to a job interview and they say, we love you, Estefania, you got the job, we're going to pay you, we haven't decided exactly how much we'll pay you, but it will be more than $100 a year. And then you say, well, more than $100 a year could be great, depending on how much more than $100 a year it is. Or it could be not that great. Could you be more specific? I imagine that's what you would ask, right? More than 100 is a pretty wide range. Can you be more specific about how much you're going to pay me? And then they say, well, we'll definitely pay you more than 50. How would you react to such an answer? They already said it'll be more than 100. You ask them to be more specific and they say, well, it'll be more than 50. We already knew it would be more than 50. All of the numbers that are above 100 are above 50. So they gave you a wider range of possibilities. That's not adding information, but the other way around is adding information. Like if they first started by telling you we'll pay you more than 50, and then you said, could you be more specific? And they say, well, it'll be more than 100. Okay, so now I'm more equipped to make a decision about whether or not to take this job. You might say, well, I'm still not that equipped. Like, still there's a pretty wide range above 100, but more equipped than I was with the first statement. So yes, a narrower range is always more informative than a wider range, always, in data sufficiency. Are you really saying there is no question that can be asked where S1 is sufficient but S2 is not? Yes, that is really what I'm asking. There's no such question. But if you find one, let me know. but no, there isn't one. The question itself here about Martin is actually a pretty hard question. But I love that we can eliminate two answer choices without even really engaging with the question itself. And I think what makes it hard is that what they're describing here, there's actually a name for this. It's called a stepwise function. And I'm going to use pen and paper here to just draw on an XY coordinate plane what that stepwise function looks like, and then how to bring this 15% into that graph to kind of see where that lies. So I think that's why they give us the graph paper, so that we can draw an accurate XY coordinate plane type graph. So I'm going to use this here, and I'm going to say, okay, here's a bill of 0. That's the origin, 0, 0. Now, if the bill was $10, that's the minimum that the bill could be, then the tip would be, I think it was $2, wasn't it? Let's put 2 here. So this is not to scale, obviously, but that's okay. Now this will be $20, and if it's more than $20, then the tip would be $4. So I'm going to start building my stepwise function here. We start from here, and all the way here in the teens, the tip doesn't change. It's always $2. And then here it jumps. It's like a step. This is why it's called the stepwise function. It jumps to here at 20, but then again it goes like this all the way to 30. And at 30, it jumps again to $6. And then again, it stays at 6. all the way up to here. And this is where you can save some time by looking at the statements, right? Because neither of the statements deals with bills above $50. Each of the statements on its own limits us to up to $50 bills, so I don't need to go any further than here. And this would be $8, and we're done. That's our stepwise function. How do I bring in the 15%? I'm going to use a different color for that. Now, for 15%, what I want to do is find a point on my graph that is 15%, where the tip is 15% of the bill. So looking at my numbers, $2, $4, $6, and $8, which of those do you think I'm going to zoom in on if I want to think about a 15% tip? In other words, which of these numbers lends itself nicely to be 15% of something?
The $6?
You're right. Yeah, I want a multiple of 3. And the reason that I want a multiple of 3 is because 15% is...
a multiple of 3?
Yeah, it's 3/2 of 1/10 of the bill. And that 3 in 3/2 is why I'm looking for a multiple of 3. So $6 would be 15% of what?
I just did a proportion. 6 to x equals 3 to 20. And then I saw that it was 120 with 3x, so it's 40.
If I asked x is y% of what? How would you solve that?
20.
You'd say x is y% of question mark, whatever it is that you're trying to solve for. And then you isolate the question mark by multiplying both sides by 100 and dividing both sides by y. That's the question mark. 6 is 3/2 of 4, so it's 15% of 40. I don't know if that's intuitive for anybody else, so I think it's fine to do it a little bit more algebraically and say, kind of like how I did it here. 6 equals 15% of x, and then solve for x. So that puts us right here. That dot, that red dot, is 15%. And the easiest other dot that I can find for 15% would be the origin. And if I connect those dots, what will I get? A line that represents, if I continue that line, that's the line that represents 15%. How do I know that? Because the origin is 15%, because 0 is 15% of 0, and this dot is also 15% because 6 is 15% of 40. And what we see here is that, not surprisingly, we can get a yes and we can get a no. And you can kind of also see, or you can visualize that if we continued this stepwise function, we might not get any more no's. In other words, it kind of appears to me like the only places where you'd get a no is here and here. And now you should be able to answer the question just from this picture. All right, the question wanted to know which side of 15% was the tip on. And in the case of statement 1, we knew the bill was somewhere between 15 and 50. And we can see from my picture that that's not sufficient because we have those blue ranges between 15 and 50. So could get a no, could get a yes. But statement 2, which tells us that we're somewhere in the 40s, looking at the picture here, where's 40? Here. We're always above the 15% line, and therefore the answer is B. As usual, I think the takeaway is you have to do all of the work before evaluating the statements, and then evaluating the statements takes just a few seconds. And if you can't figure out what work would enable you to evaluate the statements in a few seconds, then guess and move on. That's how we know that we need to let go of a question. This is a very, very, very hard question. It is a very hard question. And I want you also to consider the kind of calm that it takes to create a graph like this in the middle of the GMAT. I mean, you have to be extremely confident. You have to know exactly what to do right from the beginning. Like, yep, I'm going to draw this stepwise graph and draw the straight line for the 15%. So first of all, you have to even know that that's a thing. So now you all know that it's a thing, even if you didn't know it before, because now we've seen it. But it's not enough to just know that it's a thing. You also have to be extremely confident that it's the right thing to do in this particular question, and that you can do it in a GMAT appropriate kind of time frame. Now, I think you'll agree that this doesn't have to take several minutes to create this graph, especially if you've done it before. It doesn't take a whole lot of time to make this graph and to see that statement 1 is not sufficient on its own and statement 2 is sufficient on its own. Like, I think you'll agree that all of this is theoretically doable in under 2 minutes, but only if you've done this kind of thing before and you're very confident and very calm. This is not something that I could do if I feel like I'm in a panic mode. I couldn't do this, which goes back to what Chris was talking about, right? That the importance of just being there to have fun with these problems, and also being very willing to let go of questions. So this is a question that you can very easily get wrong and still score 50 on quant. Like, this is not a question that would pull you below 50 if you get it wrong. It probably will pull you below 51. Like, if you were going to score 51 and then you got this question wrong, okay, maybe then you'll score 50. But I don't see this question pulling you below 50 for getting it wrong. It's a very, very hard question. Hey, I'm just going to interrupt my own video for a moment here. If you're finding value in this video, please let me know in the comments below. And give this video a thumbs up. It really motivates me to keep uploading a new video every day. All right, back to the video. There is a way to do this without a graph. So thank you for the question. It's a good question. Two things. When we're at home, and I know I say this every week, but when we're at home, we don't want to feel satisfied with having picked the right answer by testing cases, because it means that we didn't really learn as much as we should have learned from that question. So I just want to remind everybody of that. And the thing to learn in this question, I think, is that stepwise function with a 15% line. So you can kind of visually see where you are and you can get both answers or not. Having said that, at the test center, my job isn't to learn from the question. At the test center, my job is to try to get the right answer in under 2 minutes. And that's where your question is very important, Victor. Is there a way without the graph to answer this question in under 2 minutes confidently? And there is a way. I just figured it out now as you were asking it. So here's the way. Here's what you can do. It's really important to look at the statements and see how the ways in which they narrow down the range. And then I would say start with statement 2 because it's easier to evaluate. All you have to do with statement 2 is test $40 and I want to say $49.99, but I mean, honestly, I would just test 50 as if it was $49.99. In other words, I would test $50 bill with an $8 tip. Because really I'm testing $49.99, I'm just rounding it to 50, but the tip would be $8. And when you test those two extremes, you prove that it's not 100% proof because weird things can happen, but I would be pretty confident then that statement 2 is sufficient on its own. It gives me a definitive yes, whether the bill was 40 or 50. And let me just draw this out here. So if it were 40 and you have an $8 tip, is that more than 15%? Yep. Yes, it is. It's 20%. And what about if it was a $50 bill? Is this more than 15%? And the answer is also yes. Why? Because $7.50 tip would be 15%, and this is more than $7.50. So I get a definitive yes for statement 2. Then you go to statement 1 and you say, okay, here's the thing. I already know that statement 1 will allow for a yes. There's a way to get a yes. How do I know? How am I so confident that statement 1 will allow for the possibility of a yes? Because the statements are not allowed to lie. The statements cannot contradict one another. So if statement 2 forces a yes, statement 1 has to at least allow for the possibility of a yes. It isn't possible that statement 1 gives a definitive yes, and that statement 2 gives a definitive yes and statement 1 gives a definitive no. That can't happen on the GMAT. If that ever happens to you, you made a mistake. It is never going to happen that the statements give you conflicting definitive answers. So using that, I can go into statement 1, having already seen that statement 2 gives a definitive yes. I can go in statement 1 and say, I already know this statement will allow for a yes. I don't need to prove that it can lead to a yes. I know it can. Which means, in order to prove insufficiency, I only need to show that I could get a no. How would I try to get a no with statement 1? What's going to be the easiest way to do that? I want to minimize the tip and maximize the bill, right? Because I'm trying to show that the tip could be under 15%. And the way to do that is to minimize the tip and maximize the bill. So what I would do is I would maximize the bill there. I'm not going to try numbers in the 40s because I already know from statement 2 that any numbers in the 40s would always lead to a yes. So I'll go to the other extreme, so something in the teens. But again, I want to maximize the bill and minimize the tip. Is this less than 15%? The answer is yeah, it's basically 10%. Like if it was $2 and $20, that's 10%. So it's practically 10%. So I managed to get a no. And again, I already know that it'll allow for a yes because statement 2 gave a definitive yes. And therefore, I can confidently pick B. So that would be the kind of clever way to get to the right answer in under 2 minutes by testing cases. So I guess the lesson there is even if we're testing cases, there's good ways to test cases and there's bad ways to test cases. And I think that most of the time, most of the people will test cases in a bad way, just kind of randomly grabbing numbers without any method to the madness, without a strategy. And that's when people really run out of time in a very big way. I mean, I've seen people run out of time on quant with 12 questions left, with 15 questions left. Like I've seen dreadful things. And this is why that happens, right? Because they say, well, I'm just going to test cases, but they don't really have a strategy to that case testing thing. This is what I would consider a really good, really clever strategy to be able to test cases and get the answer in a GMAT appropriate kind of time frame. When I first saw this question, it was on our forum. I actually didn't know this question before Parash posted it. And I read it, and I remember thinking as I got here, basically at the period, I took a long, long pause, as I always do, right? I took a long pause, and I thought to myself, this is kind of a strange way to calculate the tip. I guess this is how people do it when they're not, when someone's not a numbers guy like me. This is the trick that they use. They say, well, I'm not going to figure out exactly what 15% is, right? But the reason I'm talking about 15% is because we see that later. So I guess Martin lives in a country or in a culture where 15% is kind of the go-to percentage for tips, right? And so in other words, I'm making it real, and I'm wondering, oh, that's kind of a strange way to calculate the tip if you wanted it to be 15%. And at my pause, I'm thinking, well, in one extreme, if it's $10, that's a $2 tip, which is a nice tip, all right? It's 20%. And then he bumps it up. He bumps the tip up every time. Since I'm in Canada, we have coins here, $2 coins. It's called a toonie. It's a big coin that's has a 2 on it. So I'm thinking maybe he's in Canada, and so he wants the tip to be a multiple of 2 because he just has a bunch of toonies with him whenever he goes to the restaurant. So that's why he likes it to do it this way. So I'm thinking about all of that, but then I'm thinking the tip is going to stay the same as I go through from 10 to 19.99, and then the same thing happens again. Like in my head, a stepwise function is kind of forming itself just as I'm thinking about how this tip is calculated, because it goes $2 all the way from 10 to 19.99, and then it's $4 all the way from 20 to 29.99, and then it's $6, and etc. So the graph is already kind of in my head at the period because I took such a long pause there. The graph formed itself in my head, and from there it wasn't a big leap to put it on the graph paper that they provided me with. And then I think the trick is to figure out where that 15% line goes. There's 2 ways to do this, right? One is to just be very accurate with your graph. And the other is to quickly think about this point. I mean, this is 10%. $2 over 20. That's not hard, right? That's 10%. So yeah, that would be below the red line because the red line is 15% and this is 10%. Same thing here. What's $4 of 30? That's 13 1/3%. That's below 15%. So that's a way to kind of make sure that your graph is at least somewhat accurate and represents the reality.
But if I would just throw out 25%.
Yeah, I would just take this. That's 25%, right? $5 and $20. All right, it's 2.5 times 1/10 of the number. That's 25%. Or a quarter of the number, maybe that's easier, right? Take some number on the x-axis and then find a quarter of that number on the y-axis and you're done. $5 is 25% of 20, no? If you wanted to know what does the line look like for 25%, you'd need to connect the origin with that point. So that orange line, that's the 25% line. And what's the 30% line? The 30% line would go through $9 and $30 there. That's 30% line. This is 25% line. And our red line was 15%. I mean, I would recommend that to everyone, right? You want to practice doing this on your own. Otherwise, you'll get to the test center and be like, oh yeah, this is like that question about Martin and the tip, but I don't remember how he did it. I'll just bail. Which is, by the way, not a terrible idea to bail on a question like this. Like I said, it wouldn't push your score down from 50. But yeah, you definitely want to create a new variation of this question at home and practice this. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.